Okay, in this video, we're going to talk about wire ropes. So, wire ropes typically look like this, where you have a couple of strands and they're braided together. And you can see here, this is a pattern of one, two, three, four, five, six, seven. So, six on the outside and one in the center. And most of them come in this sort of configuration. The main difference for each one being here, it's a solid wire rope for each of the circles. The other ones could have another set of braided ones replaced with this solid. So you can see that there's different patterns in terms of how many wires fit inside one main rope. And typically, the rule is the more the more wires that's composed inside this entire wire rope assembly, the more flexible. And the less wires is going to be less flexible. So you could see that there's a lot of different types. Some that's they call like super flexible, like this one here, ultra flexible wire rope for lifting. You can see this is a really fine um, mesh here. And then you have some that's like high strength ones. So it just really depends on what your design goal is. And there's also some with certain coating to let it have like less friction if there's a lot of back and forth along a pulley. So these cables could be wrapped around pulleys to um, redirect the direction of pull, for example. So there's different ways of using it. And then in terms of terminating the rope, there's different ways to do that as well. You have clamps that you can use, and then there's certain threaded terminations. You have like clevis ends where you could wrap the rope, or you could crimp the rope. So there's a lot of different types that you can use, and some of them is just like a cylinder that you could attach at the end, or you could have a loop at the end. So there's a lot of different types, different ways you could terminate, and then there's also associated tools that you can use to do the termination. So if I scroll down, you see that there's different tools here that you can use, specifically these. You have heavy duty ratchet and pullers. Um, these ones are for tensioning. So this one right here is like a wire rope cutter. So special tools to cut the rope. Um, Yeah, so if you look at some of these, you can see more about it. So, for example, if I click, yeah, this one here is a compression tool for the sleeves. This here is a compression tool for the wire rope end fittings. You have rollers also for the ends. So, all of these are for the termination. So, based on which one you choose, you'll use a different tool. Some are hand tools, some are more powerful. So, it just really depends. So when you choose these wire ropes, you will see different diameter sizes. It goes up to 1 inch. You have different lengths, different materials, and then you have different finishes. And you can see the capacity can range from 1 pound all the way up to, you can see this is 110,000 pounds. So there's a lot of different types that you can work with. So for us, let's just take a look at a relatively small cable. So let's say we're dealing with 1/16 diameter, maybe an extra flexible one. So we'll go ahead and open one of these. Let's say we have 10 feet, for example. So we could download one of these. Actually, there's no option for downloading. Let's see, what about this one? Yeah, so this one doesn't have any option for downloading, but we could just um, do a quick sketch in SolidWorks for the representation of it. So if we go back here, we could take a look. Let's see if the other ones have any downloads. Let's see. Yeah, so these don't have any downloads, so we'll just have to sketch it out in SOLIDWORKS. But let's say we want termination. So one common termination would be like a wire rope stop. So we were doing a 1/16th. You can see that this is for 1/16th, and there's different types available. So for this, you'll need some sort of hand tool that we looked at earlier to compress it. Like this right here, you can see a compression tool. So this compression tool here could be used to do the crimping. So again, there's no available option for downloading, but we can put it in our assembly here. So let me save this. This was from last time. Okay, so let me close this. And let's go ahead and make a cable. So in my top plane, let's go ahead and sketch a 1/16th diameter cable. And maybe this is 1 feet. This is pretty long actually. Let's just make this 6 inches. And we'll call this our cable or wire rope. Sometimes you'll see the names used interchangeably. But going back to the wire rope stop, we see that this has a OD of 3/16th, and we'll just make that the same size. So new part. It's a 3/16th in OD, and the sleeve length is also 3/16th. And we know that the ID is 1/16th. So we can make this 1/16th and make this 3/16th. And we could extrude boss this to 3/16th. And we'll call this wire rope stop. So if I put it in my assembly, I could have my wire rope stop. So after you cut your cable to length, you would need to slip the wire stop in here and then place it somewhere, maybe not exactly flush, but you could place it somewhere, crimp it, and then you could cut the tip off to whatever you want it to be. And then there could be wire rope pulleys that you could work with, for example. So we're dealing with a rope diameter 1/16th. So in the case where you do want to redirect direction, you could use a pulley here. So these pulleys are different from timing belt pulleys in that this is there's no teeth on this, so it's just merely for the cables to move across. So I'm gonna save this and open it. And usually there's gonna be certain pulley diameters that's good for different rope sizes. So certain vendors will have a more detailed manual for you based on that. So if you wanted to show your assembly more properly, you could draw this angle in 90 degrees to show that it bends. But for now, I'm just gonna have this floating, so you could just see if you did want to put it in assembly, you could put it like that. And one thing that this is similar to the gears that we talked about is that you could still attach a shaft to this, and then the shaft would have a bearing that's rotating relative to, so that your assembly, um, your pulley can be spinning freely without much friction. But it just depends on if you do need it. There could be certain cases where bearing is not required, and you just have it rub against aluminum. But that's usually not recommended if you want to have any sort of high cycle applications. And then the reason for the stop is you could attach something to this block that you're pulling with. So you can imagine maybe one side of this cable is attached to a spool, maybe wrapped around, and is controlled by motors. And maybe this is actuating something that's going back and forth. So you could have, for example, a part that's like a cable pull block, for instance. So I could sketch here on the top plane. Maybe I'll make a small block, zero point 0.5 by zero point 0.5, and I'll extrude boss this to be zero point 0.5. And there could be, like, for example, a little slot here. I'm gonna sketch with my corner rectangle tool. And this here might be, I'll do, let's see, 1/16. I'll actually make this a little bit bigger, so I'll do 0.07. And then there might be another block here for the the stop. So I'll make this 4/16 to be a little bit bigger. And if I extrude cut this and select the contour, gonna have a blind cut. So I can have something like this. I'm just gonna call this a wire rope pull block. So I could have this pull block here like this. And I could have maybe this face is gonna be tangent like this. It's just floating, so it's kind of hard, but you could see that. Actually, let me delete this tangent mate. Let me just reinsert this. Okay, so I have my wire pull block like that. And then maybe I can mate this to the top plane, flip the direction. And then I could mate the front plane to the front plane. I will make it parallel. Okay, now that it's more squared away, let's see, I'm gonna drag this. The wire rope is fixed right now, but I could drag this down. And if I go normal to this, actually, let me flip the directions of these. So this face should actually be the other way. So I could mate it to this plane. Let's see, I should mate this one to the top plane. Let me delete this. Okay, so this plane should be, let's see, the top or front plane. Make it parallel. And then now if we go normal to this, we could put it like that. Okay, so now you could see that. Here's what I'm trying to show you. Okay, so the way you would insert this is you could have And there's probably a better way to make this, but right now I'm just having this floating so you can see what's happening. But you could see the idea is you could slip this wire rope with the stop in here, and then you could pull on this block. So that's the idea is this is how you would start putting something in assembly. So this part could also be threaded and threaded to something else, or you could have a lot of times you'll just see a cable with a block attached, and this wire will be pulling down, and maybe this is attached to something else and it's being actuated. So that's the idea of how you would use a cable, assemble it to a stop, and then attach it to a block that you're driving. Okay, so that's the core concept of applying a wire rope in your assembly. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one.